I'm going to talk about how we can use the negative binomial, a distribution in statistics, to determine how many times you have to mine or fish in order to pick up a certain item in World of Warcraft. So if the drop rate of an item in World of Warcraft is 10%, and I've done this 10 times, the question is, am I unlucky, and how many more times do I have to fish or mine or raid until I pick up the item? These are assumptions that I'm making. I'm making the assumption that Blizzard isn't keeping track of how long you're fishing, and they say it's too long, so now we're just going to give the fish. In fact, every time you fish, it's an independent trial. So the chance of getting the desired item stays the same each time. The probability of getting a certain fish stays the same. The second thing is that if you have the school of fish, if you are a fisher, you know when you have the sparkling water, your P is much higher because the fish are swimming together, and this is when you want a really really valuable fish. Okay, so we're going to go fishing in the eastern plaguelands, and we're going to be fishing for sun-scale salmon. Now the chance of picking up raw redgill is 35% in eastern plaguelands, and for salmon it's 12%. So for the raw sun-scale salmon has a 12% drop rate, which means the probability of catching it is 0.12. So whenever you fish, you always catch or pick up something as long as you click on the hook. So that means that the whole list of possible drops must sum up to 100% or 1. And since you're always catching something, the probability of getting something else plus the probability of getting a salmon is equal to 1, which means the probability of getting something else is equal to 1 minus the probability of catching salmon, and that's 1 minus 0.12. We know the 0.12 from here. And so the probability of catching something else is 0.88. Okay, so I'm actually going fishing here. In this movie, you'll see that I'm fishing, and I'm going to get my salmon, and I'm going to get it on the 6th try. I'm going to have 5 failures, and then finally I'll get my salmon. So my first, when I first fish, I'm going to be getting a driftwood, and then that will be followed by 5 raw red gills, I think. Let's see. Yes. So the first catch was a driftwood over there, and then I have a raw red gill, which is a failure, and then I'm going to get another raw red gill, and I will have 4 raw red gills, and then finally a salmon. So this is 5 failures. 1, 2, 3, 4, 5 failures, and finally a success where I'll get my salmon on the 6th try. So the probability of getting the salmon is 0.12. The probability of getting something else, which is the failure, is 0.88. So now I'm just going to replace these events, whether it's a failure or a success, with probabilities. So that's just what's happening here, where we're replacing the events with numbers. And you can see I now have 5.88s and 1.12. The last attempt, the 6th attempt, was a success. Okay, so what is the probability of me getting the salmon on the 6th try? It's the probability of getting something else raised to the power of 5, if I have to multiply all of these together, times the probability of getting a salmon of 0.12. So that's failure raised to the 5th power, because we multiply each one of these, times success. And that's 0.88 raised to the 5th power times 0.12, which is 0.06. Okay, my movie's finished playing, and you can see, I don't know if you can make out the font, but there were 5 failures, and finally on the 6th try I did get the salmon. Okay, so the probability of getting salmon on the 6th try is 0.06, and so we get that equation by taking failure, raising it to the 5th power, because there are 5 failures before you actually get a success on the 6th attempt. Now, what's the chance that you'll get salmon on the 1st try? And that's equal to 0.12, because you have 0 failures, and then your success is on the 1st try. And failure to the 0th power is 1. Any number to the 0th power is 1. So really it's just your rate of success, which is your drop rate of 12%. Okay, so this is the general graph of the negative binomial with one success, and the general equation is failure raised to the power of x minus 1, where x is the number of tries, times success. So on your x-axis is the number of attempts to get the sun scale salmon, and on the y-axis is the probability. And your success is your last attempt. You're going to stop after you get whatever you want. But everything preceding, all the tries preceding, are represented by this. And so if you have x tries and you get it on the x attempt, then that means that you have x minus 1 failures. And so that's why failure is raised to x minus 1. So this is the negative binomial distribution with one success, and I'm just going to show how you can get this graph in Microsoft Excel. So in Microsoft Excel, let's just type out the probability of success is 0.12. The probability of failure is 0.88, which is 1 minus 0.12. And then now we'll do number of tries or number of attempts. So let's just go from 1 to 10. Okay, so then the number of failures will be the number of tries minus 1. So if you get your salmon on the first try, that means you have 0 failures. And if you get it on the 6th try, that means you have 5 failures. Okay, so what's the probability? So we just use the general equation. So it's you're raising the probability of failure raised to the number of failures times the probability of success, the success on the last try. Okay, so your first try, your probability of picking it up is 12%. That didn't work. And that's because probability of success is constant. So I have to put $signs in front of C2. Okay, probability of failure is constant. Probability of success is constant. I have to put $signs in front of it, and that should do it. Okay, so now let's just use it with Excel, which is much easier. We'll just use the negative binomial distribution, and then number of failures. Excel tells you what to put in. That makes it a lot easier. Number of success is 1, and the probability of success is C1, and we need to make that constant. We need to put some $signs in front of that. Okay, so now you can see that the numbers match, and if we fill down, then the numbers should match, and you can see that the numbers do match. So that's the easy way you can get it in Excel. Okay, so now, we happen to get it on the 6th try, but really, what if we want to see what is the probability we'll get it in 6 tries or less? Because we're just as happy to get it on the 1st try or the 3rd try. In that case, what you want to do is you want to add up the probabilities all the way up to the 6th try. And so we can easily do that in Excel by just summing up from the probabilities from 1 to 6 tries, and that is 0.5355. We're just summing it up. And that means, what that means is that there is 54% of the time I will get the salmon in 6 tries or less. And then, so let's just do it in 10 tries or less. At a 12% drop rate, what is the probability I'll get my salmon in less than 10 tries? And so we do the same thing here, where we're summing up all of the probabilities from 1 to 10, and then the answer is 0.72. So that means that 72% of the time I'll get it in 10 tries or less. Okay, so how unlucky do I have to be where, and in statistics we use 95% and 5% as thresholds. So how many tries does it take for me where I still haven't gotten the fish, and I feel like I'm really unlucky. So if I keep on adding the probabilities all the way until I get 95%, it actually stops at 23. At 23. So if I fish for 23 times and I still haven't gotten my salmon, I'm really unlucky. That is 95 out of 100 people have already gotten their fish by the 23rd try, and I haven't. And in that case, it may be that my drop rate is suspect and it's actually lower than I think it is. Okay, so there's other examples of a negative binomial distribution. What if you wanted to guarantee that you'll have a boy in your family? Well, the probability of having a boy or a girl each time is 0.5, but how many kids do you have to guarantee having a boy? And it turns out if you have 5 kids using the negative binomial distribution, you can figure this out. If you have 5 kids, there's a 97% chance that you will have a boy. It may not be the 5th one, it could be the 1st one or the 3rd one, but there's a 97% chance that there will be a boy somewhere in there, at least one boy. Okay, what about these collectible toys? I don't know if you've seen these capsule machines where you can put money in and get these toys. And what if you want to collect all of them? If there's 4 different toys and you want a certain toy, then let's assume P equals 0.25, and then that means that you would have to put money in the machine for 10 times for a 95% probability that you'll get the toy you want. But this is assuming that P equals 0.25, that the toys are equally distributed, and sometimes manufacturers will make one toy really rare so that, of course, you can put more money in to get that last toy, and they can just get more money. What if you wanted to keep rolling a die until you get a certain number, P equals 1 over 6? To do that, again, you use the negative binomial distribution, and you can determine that if you decide I want number 3, if you roll for 16 times, there's a 95% chance you'll get that number 3. It might be in the 5th turn or the 8th turn, but you will get that number probably within 16 rolls. So that's the example of using a negative binomial distribution to determine how long you have to quest or fish or mine in WoW, and you can also use this for other things.